Hello champions, welcome back to the Bhanzu class. I hope you all are doing great and are super excited for the class, right? So let's quickly begin the class. But students, before I tell you the topic of the class, let's quickly recall about lines of symmetry and regular polygon. So if you have a figure which can be folded about a line in such a way that the two halves produced are identical to each other, then such a figure is said to be symmetrical about that line, and that line is known as the line of symmetry. Understood? And what do you mean by a regular polygon? A polygon is said to be a regular polygon if all its sides are equal in length and all its angles are also equal, right? Wonderful. Now let us do a little brainstorming here. So here's a question for you. Draw the axis of symmetry for the following. How will you draw it? Think about it. Okay, I will help you here. I will teach you a concept of rotational symmetry, which will help you in finding the solution. So in today's session, we are going to learn about lines of symmetry for regular polygon. Then we will discuss rotational symmetry, and then we will discuss special shapes which possess both line of symmetry and rotational symmetry. So let's start with the line of symmetry. So students, can you see this figure here? So here we are given some regular polygons. Now what do you mean by regular polygons? Right now I explained it to you that regular polygons are polygons which have sides equal in length and also their angles are also equal. For example, if you look here, this is an equilateral triangle. So you can see that all its angles are equal and also all its sides are also equal. Similarly, this is a square. So in case of square also, we know that all sides are equal in length. Let us say it is A. Okay. And also we know that all the angles are also equal. That is 90 degree. Right? Similarly, students, we are given pentagon and hexagon here. So you can see the angles here. And also you can see that in case of pentagon, it is a regular polygon because it has 5 sides of equal length. And in case of hexagon, again it is a regular polygon because it has 6 sides of equal length, right? Now if I'll ask you to draw the line of symmetry for these regular polygons, how will you do it? Let us see how we will do it. So in case of an equilateral triangle, we have 3 lines of symmetry passing from each of the vertex. As you can see here, if we'll name this equilateral triangle as A, B and C, so you can see students, there are 3 lines passing from each of the vertex. 1, 2 and this is the third one, right? So these line of axes, they will divide the triangles into 2 equal halves, right? Similarly, in case of a square, you can see that there are 4 lines of symmetry. What are these 4 lines? If you look here, one is this vertical line, second is this horizontal line, and the other 2 lines are the diagonals of the square, right? So we have 4 lines of symmetry here. Similarly, in the case of a regular pentagon, we have 5 lines of symmetry, and in case of a regular hexagon, we have 6 lines of symmetry. So can we conclude that if we have a regular polygon of sides n, in that case, the line of symmetry of that regular polygon will also be n, right? Because we can see that in case of equilateral triangle, we have 3 lines of symmetry. In case of square, we have 4. In case of pentagon, we have 5. And in case of hexagon, we have 6. So from this, we can conclude that in case of a regular polygon, the number of sides is equals to the number of lines of symmetry for it, right? So this is an important conclusion. Understood? Wonderful. Now let us discuss about rotational symmetry. Now what do you mean by a rotational symmetry? If a figure is rotated about a fixed point, let us say this is the fixed point in this case, O, okay, and it do not change its shape or size, then such figure is said to possess rotational symmetry, right? So we have a circle here with center O, right? And we can rotate it. So we'll say that this circle will possess rotational symmetry. So in case of rotational symmetry, we have to discuss four different parameters. So first is the center of rotation. Okay. Second is the angle of rotation. Okay. Third is the order of the rotation. And fourth is the direction of the rotation. Okay. Fourth one is the direction of the rotation. So students, what is the center of rotation for this? You can see this, the center of the circle O is the center of rotation here, right? It is the fixed point about which the figure is rotated, right? Now, what is the angle of rotation? It is the turning angle with which we are rotating the shape. So that is known as the angle of rotation. Now, what do you mean by the order of rotation? It is the number of times the shape appears to be same during one rotation is known as your order of rotation. Okay. And what is the direction? So you can rotate the circle in both direction, either clockwise or anti-clockwise. So here we will say that the direction will be clockwise or either anti-clockwise. Let us understand these parameters with the help of an example. So you can see a square here. Wonderful. Now, if you see in the first image, we are rotating it clockwise at an angle of 90 degree. So what is the angle of rotation here? It is 90 degree, because you can see that in all the figures, we are rotating it with an angle of 90 degree. Now, what is the center of rotation here? The center of rotation is this, the center of square, right? So let us name this point as O. So the center of rotation here is the center of square, that is O, right? Okay. Now students, every time we are rotating this square with an angle of 90 degree. So you can see that this is the first rotation. Okay. Then this is the second rotation. Then we have this third rotation, and this is the fourth rotation. So after rotating it 4 times, you will see that we will get the exactly same shape as that of the original figure. You can see that this point P is appearing at this corner only. It means the order of rotation for this will be 4, right? So the order of rotation will be 4 here. And what is the direction here? How we are rotating this square? So here we are rotating it in clockwise direction, right? So the answer is clockwise. Understood? Wonderful. Now let us see the next topic. Line symmetry and rotational symmetry. So students, we have seen that there are some shapes which possess only line of symmetry, and there are some shapes which possess only rotational symmetry. But there are some special shapes which possess both line of symmetry and rotational symmetry. And you can see that circle is the perfect example of it. So here you can see some circular patterns, right? So in case of a circle, we can say that the line of symmetry will be infinite, and also the rotational symmetry will be infinite. Why it is so? Because if you look at the center of the circle, right, and if we will draw a line passing through the center of the circle, that is the diameter of it, then that diameter will be the line of symmetry in case of the circle, right? So we can draw so many lines of symmetry here, right students? Wonderful. Similarly, the order of rotation of a circle is also infinite, because you can rotate a circle every time about its center, right? So we can say that the order of rotational symmetry is also infinite in case of a circle. So order will be infinite. Okay, and we can draw infinite lines of symmetry also. This will also be infinite. Understood? So circle is the perfect example which possesses both line of symmetry and rotational symmetry. Now students, it's time to see the application part of it. So remember the brainstorming question I gave you? So here you have to draw the axis of symmetry for the following. So how we will draw it? So the first figure is a triangle. So we will draw a straight line from this vertex so that it will divide these two holes into two halves. So this is the axis of symmetry here. Now in the second figure, there is a circle given to us, and these are the two holes. So we have to draw a line in such a way that these two holes are mirror images of each other. So how we will draw a line? We will draw a line which is a vertical line. Okay. Now if you look into the third figure, again it is a circle, but there are 4 holes. So first I can draw a horizontal line so that these two holes will be the mirror images. And now I'll draw a vertical line so that these two holes will be the mirror images. Understood? Wonderful. Now it's time to practice some more questions here. So let us see question number 1. State the number of lines of symmetry for the following figures. So first is an equilateral triangle. Okay, and we have to find the number of lines of symmetry. So students, as I told you that equilateral triangle is a regular polygon, right? In which all the sides and all the angles are equal, right? So if it is a regular polygon, then how we will find the number of lines of symmetry? The number of lines of symmetry will be equal to the number of sides, that is 3 here. Understood? Wonderful. Now students, if you look at the second figure, which is a rectangle. So a rectangle is not a regular polygon, but it possesses line of symmetry. And what are these line of symmetries here? One is this horizontal line which passes through its center, and second is this vertical line which passes through this center. So this rectangle has 2 lines of symmetry here. Okay, so this is our answer. Let us see the next question now. What letters of English alphabet have reflection symmetry? That is symmetry related to mirror reflection about both horizontal and vertical mirrors. So how we will find the answer of this question? Think about it. Let us take this example O. Okay, O is an English alphabet. If you will draw a vertical line here, so these two halves will be the mirror images of each other. Similarly, if you will place a horizontal mirror here, again the two halves will be mirror images of each other. So can I say that this alphabet, English alphabet O, possesses both horizontal as well as vertical symmetry? Yes. Similarly, the other letters will be just like O, we have the other letters as X, okay, I and H. Okay, so this is the answer of our question. Wonderful. Let's see the next question now. Give the order of rotational symmetry for each figure. So here we are given 3 figures, students. So if you look at the first one, and if you rotate it at an angle of 180 degree, you will see that you will get exactly the same figure, right? So what is the order of rotation here? For this, it will be 2, right? Let us see the next figure. Here we have these 2 lines in which the angle of intersection is given as 80 degree. So this is 80 degree, then it means this angle will be 100 degree, right? So let us say this point as P. So again, when you rotate this at an angle of 180 degree, what you will get? This point will come here, right? This point P will come here and it will show that this is symmetrical to the given figure. So it means in this case also, we can say that the order of rotational symmetry is 2 here, right? Now, if you look at the third figure, students, which is an equilateral triangle. So what is the order of symmetry here? The order of symmetry will be 3 here. Because if we rotate it at an angle of 120 degree, then we will get the same shape. So angle of rotation will be 120 degree here, right? So after 3 times, you will get the same shape as that of the original one. So the order of rotational will be 3 here. Understood? Wonderful. Now let us see the next question. Name 2 figures that have both line of symmetry and rotational symmetry. So that is possible only in case of regular polygons. So you can take the example of triangle, that is equilateral triangle here, which has 3 lines of symmetry, and also the order of rotational will also be 3 for this equilateral triangle. Similarly, we can take square here. So in case of square also, the line of symmetry will be 4 and it will possess rotational symmetry also, and the order of the rotational symmetry will be given by 4. Now students, it's time to summarize what we have discussed in the previous slide. So let us quickly discuss. We discussed first the lines of symmetry for regular polygon. So we see that in case of a regular polygon, the line of symmetry is equals to the number of sides of the regular polygon, right? After that, we discussed rotational symmetry. That is, we discussed various parameters of rotational symmetry here, that is center of rotation, angle of rotation, order of rotation and direction of rotation, right? And also we discussed some special shapes like circle which possess both line of symmetry and rotational symmetry, right? So that's all from today's class. Thank you so much students for joining the session. I will see you in the next video. Till then, keep learning, keep exploring and spark your curiosity. Bye bye.